All right, here we're going to do 2011 FRQ question number 4 from the AB exam. All right, we have a graph here, and it's very geometrically put together, so typically that tells us we're going to use some geometry. The continuous function f is defined on the interval of -4 is less than or equal to x, which is less than or equal to 3. The graph of f consists of 2 quarter circles and 1 line segment, as shown in the figure above. And then it says let g of x equal 2x plus the integral from 0 to x f of t dt. So it says find g of -3 for part A. All right, so g of -3 means we're going to go ahead and put -3 into our equation up there. So we got 2 times -3 plus the integral of 0 to -3 f of t dt. All right, well, we know that this is -6, and now here, notice that the limits are backwards. All right, so it's 0 to -3. In order to switch those, we got to make it negative and go -3 to 0 of f of t dt. And -3 to 0 f of t dt, we take a look, here's the graph of f. That just means find the area from -3 to 0. And if you notice, from -3 to 0, we have a quarter circle. So we can actually just use a little geometry here. Quarter circle will be 1/4 pi r squared. R is 3 in this case. So 3 squared, and that would actually be an acceptable answer for g of -3. Even though it's unsimplified, that's okay. You can't see it, but there you go. Perfect. All right, so we just plug that in, and there is g of -3. Now the next part says find g prime of x. All right, so if g of x equals 2x plus the integral of 0 to x f of t dt. All right, so when we take a derivative, we're going to take a derivative of each part of this. G prime of x is going to equal 2 plus, all right, we have an integral. So when we take the derivative of an integral, this is my favorite theorem, fundamental theorem of calculus part 2. All right, so we're going to take this by doing derivative of an integral. All we're going to do is plug in the x, and since the derivative of x is 1, that's just going to stay f of x. All right, minus, plug in 0, you get 0, so that's okay. Or times the derivative of 0, which is 0, so that's all we get. All right, so then they ask you to find g prime of -3. All right, g prime of -3, we got to go back to our picture. I'm running out of a little bit of room here, but let's scroll down here. G prime of -3 is just going to equal 2 plus f of -3. Well, if we go to the graph, f of -3 is just what is your graph equal on the graph of f at -3, and that equals 0. So this is going to be 2 plus 0, which gives us 2. And so g prime of -3 is 2. And that's all for part A. All right, let's take a look at part B. Determine the x-coordinate of the point at which g has an absolute maximum on the interval of -4 to 3. Justify your answer. All right, so let's get some room here. Now, if we're talking about absolute max, all right, first off, we need to remember that absolutes, we got to make sure we check the endpoints. All right, second, we got to look for any relative maxes. Now, relative max, in order to find that, we got to figure out when g prime of x changes from positive to negative. All right, so in order to do that, we got to actually look back at our g prime of x. Now, remember, g prime of x was 2 plus f of x. So in order to figure out where it changes from positive to negative, we've got to figure out the critical numbers. And so we need to take a look at when this equals 0. Now, when you set this equal to 0, we're actually looking for when is f of x equal to -2. So if we take a look at our graph, we see that -2, f of x is going to hit it right there. All right, so we need to take a look at that value as well as our endpoints. We got to figure out what that value is. So if we take a look at it, it's just a value on a line. So if I can figure out the slope of the line, I can set it equal to -2 and solve. So let's figure out what the equation of that line is real quick. We see that it has a y-intercept of 3, and if we can figure out the slope real quick, the slope is going to be down 3. Oh, can't use that one, so let's use our actual point that we have. So down 6 over 3. So if we go down 6 over 3, our slope is at -2. And so the equation of that part of the line is y equals -2x plus 3. All right. Now, that's the equation of that line, so we want to figure out when does it equal -2. So let's set it equal to -2 and solve that real quick. So if I do -3 minus 3, this is -5, equals -2x, divide by -2, x is going to equal 5/2. So now I have the values I have to check. I have to check my endpoints, -4 and 3, so -4, 5/2, and 3. Alright, so this is going to be a little table that we make. This is our x value, and we are trying to find the absolute max of g. So we're going to actually plug this in and figure out what we have going on here. So for g of x, remember the equation for g of x is 2x, so 2 times -4 plus the integral of 0 to -4 f of t dt. Alright, 5/2, we'll do 2 times 5/2 plus 0 to 5/2 f of t dt. And 3, 2 times 3 plus 0 to 3 f of t dt. And we got to figure out which one of these is the maximum value. So let's start off with the easy one here. Alright, let's do 3. That's going to be 6 plus, let's get rid of this here for a second, the integral from 0 to 3. Well, if we go from 0 to 3 on this graph up here, alright, 0 to 3, what happens is, remember, you're dealing with the area under the curve. We got a triangle here and another triangle underneath the x-axis. Now, they're the same triangle. And so if you have a positive value here and a negative value here for the integral, that's actually going to work out to be 0. So our value for this is 6. All right, let's do 5/2. 2 times 5/2 gives us 5, plus, let's figure out 5/2 here. Now, going back to our graph, 5/2, we'll say that puts us at right about here. We have a triangle here, which based on our points, this should be 3 over 2. And if that's 3 over 2, we have a triangle plus 1/2, a base of 3 over 2 times a height of 3. And then we have this other triangle down here. Well, if this is 5/2, this is going to give us a height or a base of 1, so 1/2 times 1, and a height, this goes down to 2. Now remember, we're going to have to subtract that because it's below the x-axis. It would help if I put this over on the right part. So this is 1/2, 3/2 times 3 for that first triangle, and then minus 1/2 times 1 times 2 for that triangle below the x-axis. Alright, so we figure that out real quick, because we do have to figure out what this value is. We have 5. Here, this is going to give us 9/4, minus, this is going to give us 1, which is 4/4, and altogether that's going to be 5 plus 5/4, and if we get common denominators, that's going to be 20/4, 25/4, which is a little over 6. Alright, so far that's in the lead for our max value there. And our last one, well, this is going to be -8, starting us off. Plus, we know we have to switch this, so this is going to be a minus the integral of -4 to 0 of f of t. All right, I'm betting this is going to be much less than 6, but let's just take a look at it anyway. So -4, well, this is a very big area. This is a little area, and since it's negative, this is going to end up being a negative value. So we don't even have to go any further with that. So our maximum, absolute maximum, remember we're looking for the value, or we're looking for determine the x-coordinate of the point at which it has an absolute maximum. Our x-coordinate would be x equals 5/2. Would give us our maximum value for g of x. Okay, a little bit more work for this one, but not too difficult. More just computations, figuring it out. All right, so our max value is where g of x has a maximum, absolute maximum. All right, and our table should be enough to give us our justification points on this one. All right, so let's look at our next one. All right, find all the values of x on the interval of -4 to 3 at which the graph of g has a point of inflection. Give your reason for your answer. All right, well, this one won't take too long, because whenever we deal with points of inflection, we got to look at one of two things. We either have to look for when g prime of x changes from increasing to decreasing, or decreasing to increasing, or we can look at g double prime and we can just look to see where that changes signs. So we already said what g prime was. G prime was 2 plus f of x. All right, well, with that 2 in there, I'd be leery about trying to figure out the increasing and decreasing of that, but really the plus 2 is just going to shift that whole graph up 2 units. And if it's going to shift it up, it's not going to change the increasing and decreasing values of that. So we can see that this is going to change from increasing to decreasing only once, and that's going to be at x equals 0. There isn't any other spot where that changes from increasing to decreasing or changes from decreasing to increasing. Now, if we were to want to look at g double prime of x and look at the signs, we'd have to then look at f prime of x. And f prime of x, we'd have to sketch this derivative, which we can do because we've practiced this throughout the year. And let's do a quick sketch of this. Give myself a little more room here. All right. Here we have all positive slopes. Now, here we have a vertical, looks like a vertical tangent line. So we have close to 0, and then it goes up. Here it's really vertical and goes close to 0, so it's going to do one of these deals. And this, we already said this is a line, so I'm going to do an open circle there. Line has a slope of -2. We know the derivative of a line is always the slope. So the red is our second derivative. And the only place that that changes from positive to negative or negative to positive is x equals 0. So our only point of inflection is at x equals 0. And our justification is because g prime of x changes from increasing to decreasing. Or we could have done g double prime changes signs. Either of those would be a good enough answer. All right, for our last part, part D, this has been a long one. Find the average rate of change. Now, average rate of change should be sparking some bells in your head. Average rate of change is always going to be the slope. All right, this is always the slope between whatever values they give you. So in this case, they want it between -4 and 3. Well, they gave us those points, -4 and 3. So we're going to find the slope between -4, -1, and 3, -3. So that's going to be -3 minus -1 over 3 minus -4, which is going to give us -2 over 7. Okay. Piece of cake. Now it says, there is no point C between -4 and 3 for which f prime of C equals the average rate of change. I explain why this statement does not contradict the mean value theorem. Well, remember, mean value theorem has some conditions. Mean value theorem, it has to be continuous on the closed interval of A to B, and it has to be differentiable on the open interval of A to B. Now, this particular graph is continuous, but if you notice, it's not differentiable. All right? F of t is not differentiable on the interval of -4 to 3. And we can tell that at x equals -3, it's not differentiable. And it's also not differentiable at x equals 0. At x equals 0, we have that sharp point there. And so those would be the two values where it's not differentiable at. All right. And that would be great for this problem, and that wraps up question number 4.